Welcome to the demo session on a complete advanced professional project on structural analysis and design of a commercial building using ETABS 2019 and SAFE 2016. We are doing this real project. This project we are doing in ETABS. It's a commercial building project with, you can see here is the shear wall, basement wall, lift core, staircase, etc. We will do this complete project in ETABS. I will show you the demo. This is the complete project in ETABS, and let us look at the render view. We are doing this project, this real project from the beginning to the end in ETABS. We'll do the superstructure analysis in ETABS while we'll do the foundation analysis in SAFE software. We can do manually also foundation design. Now I will show you the course curriculum here. Introduction to project and software. We'll discuss which project we are going to start and about the software. In module B, we'll define the grid line, material, section properties, diaphragm, load combination, load pattern, mass source, and load case. We'll define these parameters in ETABS. In the module C, we'll model of structural members like beam, column, slab, staircase. Underground water tank is also included in this model. For the underground water tank, it is very important to know the water pressure and the direction of the water pressure, whereas for the basement wall it is necessary to know the swell pressure. We'll also learn how to design it. I will show you here. We'll learn how to calculate this swell pressure and as well as water load calculation in ETABS. Water loads on the staircase as well as the swell pressure calculation, also the water pressure for the slope based. We'll also learn how to do this. Let us go to our syllabus. Water tank, basement wall, shear wall, lift core, ramp. We'll model ramp also in this model. And for shear wall we have also design sheet. We can extract the data from there and we can give your input and know the output. And I will also teach you about this process too, not only this Excel sheet, how to design. Now in the module D, we'll assign the loads, assign date and inputs loads, assigning lateral loads, assigning water pressure and swell pressure, assigning diaphragm, assigning floor meshing and auto edge constraint. We'll learn the actual process of applying the date as well as the live load. We'll learn it in actual form. I've developed a sheet for this also. For the wall load we have also sheets including the plaster load. For the floor load, including cement pouring, tile finishing, marble finishing. This I have. We put the water tank on the top, so we have to calculate the water tank load also. For the staircase we have to give the step loads also for first flight, second flight and for third flight. We'll know the actual process of applying the loads in ETABS. Why we need the dynamic analysis as per code, initial scale factor and final scale factor as per code, matching of base shear values between two methods. This is for the dynamic analysis by the response spectrum method. We can look here also why we need that. I will show you that. Why we need dynamic analysis, we will learn about that. Look here, in the clause 7.7.1, linear dynamic analysis shall be performed to obtain the design lateral force, design seismic base shear and its distribution to different level along the height of the building and to various lateral load resisting elements for all buildings other than regular buildings lower than 15 meter in seismic zone second. While in the seismic zone B, we shall have to consider for the dynamic analysis also. We'll learn why dynamic analysis is required without shear wall and bare frame with shear wall, and also scale factor determination for horizontal acceleration as well as the scale factor determination for vertical acceleration in response spectrum analysis. We'll talk about that. We'll match the values also. Calculation of base shear value, comparison between equivalent static method as well as dynamic analysis method, stiffness modification factor. We'll talk about this. And main important is the design check in ETABS. We'll learn how to check the model participation in frequencies, fundamental natural periods, fundamental natural periods, that the first two modes will be always translational and the third modes will be rotational. We'll talk about that, and if it does not if we do not acquire that value, we'll talk how we can acquire that also. And modal mass participation methods, PMM interaction ratios, river percentage, stiffness irregularity, mass irregularity, drift displacement, building eccentricity, torsional irregularity, beam column capacity ratio, strong column weak beam concept, stability index as per IS 456 2000 Annex E, P delta check, consideration for buckling analysis. We'll talk about this. Advanced design checks parameters in ETABS 2, and design checks in shape. We'll check the settlement check, bearing capacity check, as well as the punching shear value check. And design of members, will design the raft footing in shape. Design of the pile foundation, we'll talk about this, since this course is mainly focused on the raft foundation, but we'll talk about this pile foundation also. Design of pile cap, design of column and beam, design of shear reinforcement in column and beam. We'll learn how to design of the column. We have there for the column, here we have for the shear wall, we have also design sheet. For the staircase also we'll talk about it. This is for the strap beam design, this is for the two-way slab design, and this is for the strong column beam concept. This, and here we'll learn the accurate method of let me see there, we'll learn how to design the main column bar, also column tie bar, how we can design the column tie bar. We'll talk about that, and mainly we check about this shear reinforcement in ETABS, how we acquire the value and what is the actual value for the shear reinforcement in ETABS. Normally we put the 8 mm diameter stirrups, whether it is sufficient or not. We'll check that in detail also in this course. This is modulus of subgrade reaction. It is required for the design of the foundation. We'll talk about this in depth. And ductile detailing of structural members, ductile detailing of column, beam, slab, staircase, basement wall, shear wall, lift core. We'll talk this, how we can do the ductile detailing in AutoCAD 2. And preparation of structural reports and EBPS entry data. We'll learn how we can input the EBPS format. Here I have show you the EBPS format. We'll learn how we can fill this format so that we can submit it to the required municipalities and other higher authorities too. And at the last we'll do the live discussion on problem associated to the project. If you have any problem associated to the project, then we'll try to clarify all that problems too. Thank you for the demo class. Have a good day. Take care.